Alright, we're continuing to repair this EPSON HX-20 that I got on eBay. And this is part 2 to a 2-part video, so if you haven't seen part 1, go back and watch it. At the end of part 1, I made this battery pack and it didn't fit in here. So I kind of took it apart and redid it so it was a little more compact. And I arranged it different, so you can see the red wire's a little tight, but now it fits in there fine. It may be a little big, you can see the plastic's deforming slightly, but I think that's how that's going to stay. So now we'll move on to the other parts. So I set the cover back on here and it does fit right now and everything is working like it was before. And I noticed on the last video it's kind of hard to see the screen. It is pretty readable in person. So that's mostly just the camera making that blue smudge worse, but it is still a blue smudge right across the screen. So this is the printer. I don't know much about this. The internet seems to think this is a thermal printer, which it may be, but it has a cartridge. So I don't know if thermal printers have cartridges. I thought they had thermal paper. But I have paper here, which looks like regular paper. So maybe it's like a dot matrix kind of ink printer. But anyways, you can still get cartridges, a standard like cash register kind of cartridges. So I've ordered one of those, should be in a few days. And I hear you can get paper. I didn't try to find any, but I imagine if they have cartridges, they have paper. So here's the printer. Whenever it did cut on that first time, when I first got it, I've cut the printer on button and hit paper feed, nothing happened. But looking inside here, you can see the gears have a bunch of crud on them. And let's even turn. Yeah, but it's hard to turn. I think it's a gear motor, so that may be normal. But need to clean the gunk off those gears definitely. I don't know what feeds it. Not sure if there's another motor, or might be maybe this motor somehow switches gears and drives that. Not sure. Hopefully we're not missing pieces, but I'm going to clean that up and we'll stick it in there and see if it does anything. So I plugged the printer up here. This is the top cover. See, there's a printer on and off switch, and then there's a feed. So I'm going to press the feed. Oh, you can hear that. It's kind of making a clicking noise. It's definitely not turning. I haven't put any lube on it or anything. I might stick some let's see, what do I have? I got some lithium grease. I'll stick some lithium grease down in there and kind of turn things and loosen them up and see if that helps. If not, we might have to take this thing apart. So I put some lithium grease in some different spots. There's a slot there. Of course, it's just on the top. And put some around those gears right there. There is some dried up, looks like some dried up grease or something in it. I tried to get most of it out. It's hard to turn the mechanism. I don't want to break anything. So what I'm going to do, so the motor, I only see one motor on here. I don't know what's under here, but I'm guessing that motor just kind of drives everything somehow. I'm going to put 5 volts on those 2 wires. They don't go to any circuit or anything. They just come here to the ribbon cable. See if the thing turns, and maybe it'll work that grease in and lubricate itself. Well, it's going. It does kind of sound like it's struggling. I think I'm going to try to get some more grease in different places and run it a little more and see if it starts going a little smoother. I've been running it for a little while. I think it's running pretty smooth. So I'm going to stick it back in the machine and see if that paper feed button does anything now. Okay, it's back in there. I didn't actually know where it went before. I don't even know if I had it in the right way. So anyways, I think it's in the right place now. So printer's on. Let's cut printer off. Cut the power on. Cut printer on. Alright, that's working. It's interesting, the little wheel, the little roller wheel over there, I was wondering how it worked because it didn't have a gear hook to it. But it's got like a little lever that advances the feeder by one little click every now and then. You can see it just kind of clicking along. So anyways, I can't really test that anymore until I get the ribbon in, but at least it is turning. So I think we need to look at the cassette. So here's the cassette deck. It's a cool little module. I did spray some deoxit in there and into the connector it goes into. This did come with a few cassettes. One of them's here. It came in this case. It's unlabeled. And the other one's here. That one looks really bad. Both of these look kind of rough. Not sure how to open it. And definitely kind of nasty. I don't know if that's, yeah, some rust. I guess some water's got into this. So I don't know if these tapes are any good. But this one has a label on it. It says SPI TLER Spittler 42187. And then some names, I think. You can see those. So I'll put the better of the two looking tapes in there. I don't know if there's an up and a down. We'll put A up. And then this slides in like that. If we say load, it should try to load from the tape. It says PP error. Alright, well I think that before we do too much, we'll do Control at to initialize again. Alright, so now we have a normal menu again. Go to Basic. Type load. It says searching. I don't hear anything. Oh, I do hear something. Let's see. Get my head down here when I hit enter. It's making a noise. It doesn't sound like a motor running, but it's really quiet. I don't know if a motor is trying to turn or if it's turning and there's no belt on it. So I think we're going to take that little guy apart. I got the screws out, so let's try to open this thing up. Of course, everything's upside down. I think we're going to have to take some more screws out. Alright, I'm going to try to get that PC board off so we can at least get down to the motor. So I took the screws out. I actually had to unsolder a little stud right there. So I don't know if this is going to come up. There's a lot of wires. Almost seems like I'm taking it apart wrong. Like this whole mechanism is supposed to come out of here somehow. There is a belt on the motor. It actually has a little tensioner, which is kind of cool. It's still fine. See if I can find something to stick down in there. Yeah, the belt might be fine. Or if the mechanism's just stuck. That one turns fine. I don't think the motor's turning though. So maybe the motor's just stuck. Doesn't seem to be a good way to get it apart. Okay, well there's a motor over there too. Lose my parts. Let me see if I can get these motors free. Well, I did get the board to come up a little more. I don't know if you can see in there. I can see. I don't know if you can see. The motor turns about a quarter turn and then it seems to get stuck. So the wires to power the motor are these red and black wires, I'm guessing. But then there's these two like pink wires or something, orange, go into this thing on the top. I don't know if that's some kind of a encoder so it can measure speed. But I can get to the screws if I move this PC board around. So I'm going to take that cap off, which should give me access to the top of the motor so I can spin it. As I got that cap off, it's kind of neat. I can see this is like a coil of wire around it, and I'm guessing maybe that black thing on top of the motor is a magnet, so I guess it was some kind of an encoder. It's kind of interesting this board's all surface mount. The other board was all through hole. I guess maybe surface mount was more expensive back then. It's definitely the way to go now, but let's see if, oh, you know what? The belt's just stuck to it. Let's see if I can free that belt up without breaking it. If it does break, I have a universal belt kit. We can probably find something that's on there good. Well, it came loose, but now the belt's really loose. Wonder if we can replace that belt without unhooking all these wires. It's another little piece. I think this was on. I think that one on top of the motor. Well, I'm going to work on that a little bit and see if I can. I think I'm going to have to take something apart. I don't know if I can do it with this PC board on here, but try to at least get that belt out. Trying to get this down where you can see. So there's this bar that goes across the top here. I'm cut on a light so you can see in there. So this bar goes across there, and I was saying that's a tensioner, but it's not. It's just a belt. So the two screw holes that I used to take that screw and the one on the other side off, if I move the PC board around, I can get to that one and to this one in the back. So I'm going to take this piece off, and I should have access to the belt. Okay, so there's that piece, that other piece, and that belt. So luckily this belt isn't gummy, because that would be almost impossible to clean without unsoldering all these wires. But I'll go through my universal belt kit and see if I have something close enough to fit. Okay, it's an eBay universal belt kit. See, that's probably too big. That's too big. Let's see. About that one. It's a little smaller. I'm going to try to stick that one on there. Unfortunately, this one's a little thicker than that one. So we'll see how it sits on the belt. Alright, well that's all back together. That's got a lot of little spacers and stuff that that are under the board that fall out when you take the screws out. So if you do that, definitely keep track of everything. The belt was a little too big, but I think it's going to work. And by big I mean tall, not big in diameter. But I think everything's back in place. There's actually another little encoder under here. It's pretty cool. It's a pretty impressive little compact machine. So I can put the cover back on it and we'll plug it in and see if things turn now. Alright, let's see. Got the power on. We'll go to basic. Say load. I'm still not getting anything. Well, that's a bummer. May not be doing that right. I don't know if that's actually, may have to enable it somehow or something. So let me do a little research on that. So here's something interesting. If I go to ski rider, I guess, number 3, it asks me if I want to load from the cassette. If I press 2, it says, sorry, no micro cassette drive. Press any key. That makes me wonder, do I even have it plugged up? Maybe it's one of the ribbon cables. So let me check that. I bet that's what it is. Yep, there it is right there. You plug it into there. Alright, cassette drive plugged up. Go to basic. It's doing something. I/O error. It moved a little bit. Let's take that cassette out. The heads are moving in. The drive's not turning. There. It's moving a little bit. Yeah, I think something needs some lubrication. Alright, I'll work on that a little bit. Alright, so it turns out that belt was a little too tall. I looked online to try to find one just on eBay and I didn't see anything. So I'm trying to slice this one. So I put it around an old Flux-Off can. And I thought I would just be able to slice it, but you just can't do that with rubber. So I've actually been doing kind of a... I cut one of them, so I got it. This is going to be the good one in this. But I'm going to lose, and I just kind of push down and push like that. It's a really slow process, but I'm working my way around. Hopefully I end up with one good one. And stick it back in there. Alright, the drive's back together again. I tried to keep that belt consistent, but it's pretty tough to do. It's really small. I don't quite see well enough to do that. So, see what we get. 2. Oh, it's turning. It says searching. It doesn't say I/O error right away. Alright, let's try putting a disc in it. Okay, side A. Doesn't go on that easy sometimes. Can we rewind somehow? I don't know. Okay. It did turn for a second. It got stuck. Let's try again. I wonder if it's saying out of error because it's not finding anything. I don't know how to rewind. Okay, well I need to figure out how to rewind the tape. Okay, I got it. So we're in basic. We press Control and cassette, and then it'll list a number up here, which is where it thinks it is on the tape, but I can't imagine it knows, considering it's in a random place right now. So we hit rewind. And now it's at the beginning. I don't know how to reset that. That's not it. So we'll quit. Let's go back into it and see what it said, where it says it's at. Okay, so Control cassette again, set it back to 0. So let's quit that, and now let's try to load. Alright, let's try that other cassette. At least says it has something on it. Spittler. Kind of sounds more like might be text. So we will do Control cassette, rewind, and then Control. No, it's not working that time. Maybe it's Shift cassette. Okay, so load. Doesn't seem to be finding anything there either. At least the cassette seems to be working. I mean, at least it's moving. So rewind again. Why don't we go to Ski Writer and say use cassette. Load cassette. Document 1 maybe? Well, it doesn't seem to be finding anything, so either the cassette's not working or there's nothing on them. So I hate to write over, do a write just because there might be something cool on them, but I don't have any of these little cassettes. So it's late, I'm going to go to bed, but I think that we need to just write a program to them and try to read it. So I'll see y'all tomorrow. So I played around a little more with the tape deck trying to see if there was anything on those tapes, and no success. And then after a while the tapes deck stopped spinning, so that belt either fell off or broke. I guess my little modification to the belt didn't hold up. So imagine I had some thin spots. So it was hard to keep the belt width consistent. So I found a website that said that this is a 50 millimeter diameter by 1 millimeter square belt. So I found that on eBay. It's like $10. Seems a little high for a rubber band, but that's in the mail. So whenever that comes in, we'll just put the correct belt in there. And I also bought some tapes. So I don't know if that stuff will make it this week, but as soon as that comes in, we can continue experimenting. At least we know it mechanically works. And so we'll just have to see if there's any other electrical issues, or if it was just an old tape, or if I'm not doing it right. But anyways, this is the cartridge that came out of the printer. You see the belts. It looks like it's stretched. I don't really know. And I didn't actually try to stuff it in there and see if it worked since it was so loose. But you can still get those. Bought this. Came in today. And this is the paper that came out of it. The end of it was pretty torn up, but just cut that off. And this is supposed to be standard 2.25 width paper. So used in a lot of typewriters. I mean, not typewriters, calculators. So let's see if this printer works. So I'll cut it on, cut printer on. Also, I found this ski rider does not come on a HX-20. I don't know if they came on some of them and not on some, but it was an aftermarket add-on. It's actually one of the ROMs in here has that program on it, so that's kind of cool. It came with that. So I read over how to do this a couple days ago. I don't really know if I know the details, but I think you stick that there. Well, that's not right. Feed this in there somehow. There was some pieces of, when I pulled this out before, there were some pieces of paper stuck in there, so I don't know if there's still some debris in there. But I thought you just stuck this right there. There we go. I think it's pulling through now. So it's coming up here. Yeah, there's a piece of paper. Use a tweezer because David Tippin said that looks cool. Alright, so it is feeding. So let's get this open. See how many pieces I can get this in. Alright. There's that. And it said to slide the paper between the ribbon and the case right there, and then snap it down. Okay. So to print the screen, you hit, I think, Control F2. Oh, it's kind of working. So it's working, but it looks like it's rubbing ink across the top. You know, it kind of seems like it said it might do that in the beginning, and to just kind of go a little bit, then it'll stop. But I'm not sure if that's right or not. There might be some more paper still stuck down there. Printer does seem like it's working though. There's just a lot of extra ink. I wonder if this is the right paper, because because it did say, and I know everything says this, but to use the correct paper it won't work right. So maybe this paper's too thick. Maybe I don't have it in there good. I don't know. I'll investigate that a little more. Close. If you can see right here, there's like a metal thin plate, and the paper's coming behind it, and behind that metal plate is where it was picking up all the ink. I bet that that ribbon was supposed to go in front of that plate, and probably when I slid it on there I got it behind that plate. So I'm going to try to put it back on there again. That went on a lot easier than last time. Alright. Control. That looks awesome. That's great. I think we have a working printer. So, what's next? Well, the main things I wanted to get done were the printer and the tape deck. The tape deck's not going to get done right now since we're waiting on parts. So let's move on to the serial port. I did try to wipe this white residue off, and you see it wipes away, but then after it dries it comes back. And there's the battery pack. And I did clean the terminal pretty good. The actual plug from the power supply looks good. It's just the terminal that looked bad. So none of that white residue is really seen because there's a cover plate that goes in there like that. So I think we're looking good there. These are RS-232 and serial output. So the serial output's also RS-232. It just doesn't have all the extra handshaking signals. It's just the serial data. So this one's just a standard COM. I think it's listed as COM1 or COM0 RS-232 output with all the handshaking signals that you would expect. And this is made to hook to a modem or whatever other type of device. So we definitely like to have that work so we can interface with other devices. And this one's neat. This was designed to run with a hard drive. It's a high-speed serial line. This one's configurable between a couple different baud rates. This one's high speed. I'm not sure what baud rate it runs, but it's actually the same serial line that runs between the two processors in here to interface the main processor with all the peripherals. So it has I've just read this online on different websites. It has a protocol called EPSP, which I assume is EPSON serial protocol. And it has commands for communicating with external hard drives or floppy drives or whatever, and also with a terminal monitor. And I saw a note on one of them where somebody, I'll put the link below because I can't remember what the site was, but somebody actually started reverse engineering the messages, and it said on some models it had some keyboard input, so it looks like they had full support for a terminal on some of these. So this went to some type of device. I don't know what it looks like. I can't find it. I don't know if it was ever produced, but I've seen it called a docking station or monitor interface. And I imagine that was a box that needed power that plugged into here, and then you could plug it into a monitor. So so anyway, I'd like to get that one working because that'd be fun to play with. I also found a website, I'll put that link below too, where somebody reverse engineered that protocol and made a computer program. They have a Windows executable you can download. I don't think they had any source code or anything, but apparently you can plug this into a serial port or a serial to USB device on your computer, and it simulates a graphics mode and I think a couple text modes. So that's pretty neat. I think that just kind of based off of the protocol messages, I didn't see any way that explained how to do it, that this screen probably cuts off when the main screen's on. Be cool if they're both on, but I imagine just one of them's on, and then of course there's multiple modes on the monitor. So Yeah, I'd like to get that working because that'd be fun to experiment with that protocol and maybe make some emulators using like a Raspberry Pi or something. So it'd be cool to make a little dock. I don't know if one never existed, it'd be neat to actually make one. But yeah, so it'd be nice to see if those work. These are the devices where the corrosion was. So, you know, the solder joints kind of look okay. They're very corroded. They have that nasty corrosion layer on them that you get whenever battery acid leaks on solder. And it's very hard to work with. I know I believe the last video I talked about it was difficult to get the solder to melt. So I'm probably going to need to go through some of that. But let me see if I have DIN connectors already. I need to see if I have DIN connectors that'll work with this. I have. So looking through my stuff, I have, this is a 7-pin, and this is a 5-pin, and I also have a 4-pin. So this serial interface is 5-pin, and this one's 8-pin, which is probably the one we're going to start with because it's the more user-friendly serial port. Since it's just a standard serial port, we can just send data and receive it from BASIC. So this 7-pin will plug into that 8-pin, but we don't have the center pin. So I need to look up the manual and figure out what that center pin is and see if it's something we actually need or not. Here's the pin out for the RS-232C interface, and you can see pin 8 here is the carrier detect pin, which sometimes not all the signals are required, but if you look at the flow diagram, it actually uses all of them. So it needs a DTR to be on, DSR, RTS needs to be on in order for it to transmit, and this carrier detect signal needs to be on in order for it to receive. So we do at least need to get 5 volts on there somehow. But so from the manual, here's the interface recommended for connecting 2 computers that are both masters. You know, normally it would be a computer connected to something like a modem. And these signals names make a lot more sense whenever they all have a function kind of related to a modem. But you kind of need to trick some of them in order for it just to communicate between 2 computers. So, well, what I did to the DIN connector is I drilled a hole in it and I added a piece of wire to use as a pin. I kind of ground the end off of the wire with a Dremel tool to round it off so it'd go into the connector. So we have a full 8-pin now. I'll have to order a proper DIN connector. But we'll use this wiring configuration here. Basically it crosses the RX and TX so that they can talk to each other. Because when this one's transmitting, it needs to go into receive over here. The RTS signals are ready to transmit signal. This is a clear to send signal, or ready to send and clear to send signal. So it basically shorts them together, which will put this computer in a mode that's happy to send, and that'll get fed over to that carrier detect signal saying that this one's okay to receive. So just by, and the same thing happens over here, RTS to CTS is connected to the carrier detect over here, and then these signals just get crisscrossed as well so they can communicate. Yeah, and there's a ground wire that needs to be connected, and there's also a shield listed on here. I think it's this last one, so we won't have that one connected at all. But so basically that's what I need to make my cable look like. And this is a partial pin out for the DB9. I didn't put all the signals in there because at the time I didn't think we needed them all, but they're all listed here, and that's the pin numbers for a DB9. I have a RS-232 to USB converter here that we'll use to connect it to the computer and run a terminal program so we can try to communicate with the HX-20. And I've read online that sometimes not all these signals are supported. If that's the case, we may end up having to jump some wires across here to make it work right. But this is a nicer cable. I think I got this from Radio Shack, so hopefully it fully supports RS-232C, and we can just make a cable and it'll work. So let's get started on that. I'll make that and come back and we can try it. Of course, I could wire things wrong. I could be wrong about how I interpreted some of these signals, and my terminal software couldn't work because I don't know that I've ever I've never actually tried it, so on this computer. So hopefully we won't have too many things to troubleshoot where this will be a big hassle. But I'll get all that wired up and we'll start on that. Okay, here's the cable. Hopefully I wired everything right. It's a bit of a brain twister going between all the different pin numbers and stuff. But we'll plug this into the RS-232 port. And into that we will plug our RS-232 to CAN adapter. And then we'll have to hook it into a computer, so let me get that set up and I'll be back. Alright, I kind of got you set up here at an angle so you can try to get everything in here. I imagine you're not going to be able to read the text on there, but try to get it set up. That's my doggy Roscoe. So, plug the USB. This is a Chromebook. Been playing around with this Chromebook lately and trying to see what all I can do with it. So I'll plug it into there. It's going to ask me if I want to use Linux or Android, so I'm going to use Android. I typically would have installed PuTTY on Linux or something. You can do a lot with these computers with Linux installed on them. But since it is a Chromebook and it has a Play Store, I figured why not just download some terminal app and see if it works. So we're going to try that. It's another first. Add to this list of unknown issues. So let's see. We're going to have to write a little bit of basic code to see if this works. Those are available baud rates right there. So let's set it up for one of those. Let's just pick 600. That's right in the middle. So connect our USB device. Looks like it's already connected. Let's see. Go to settings. Let's change our baud rate. We'll do 2400 because 2400 is on the list and we don't have to make a custom one. 8 bits, no parity, 1 stop bit, flow control lines off. Actually, I guess we need them on. Let's cut them on and see what happens. So it's saying it's got some status. It says it has RTS highlighted and DTR highlighted, so we can see if maybe those change. And let's try to connect. It says it's connected. Whenever I plug the USB device in, it asks if it was a PL2302 or another driver. I picked that one because that's a likely one. But if that might be the issue also if it doesn't work. So I will cut the HX-20 on. Go into basic. And a star popped up there. I mean, some kind of symbol popped up there. So there's something. Well, we're randomly getting symbols. There's something happening. Did that when basic loaded. So that's interesting. Okay, so we need to say open, and then we need to say, I guess we can only do output or input with one open command, so we'll set it for output. I can't see the screen. We'll make this number1 file. We want to open COM0, and the parameters for the COM port are So first we picked bit rate. We said 2400, so it's 5. Then we picked word length. We chose 8 bits. Parity, no parity, so N. Stop bits, we said 1. I think I'm missing something. Let's see. Okay, so that was a whole page describing what that last number does. That's not the page there. There it is. And basically it sets what control bits you want to ignore and which ones you want to use. So it looks like with the minimal setting, all we have to support is the RTS. So why don't we, let's see. Yeah, let's do F to start with and see if we get anything. So we'll put F. Keep pushing the shift, it's already capitalized. Alright, F. Go back and find my sheet. Alright, so I guess it opened it. I believe that these two, it's really hard to see, but I believe these two just turned green. Maybe even the CTS. It looks like only DSR is white now. There's like a little line under it. So I think something changed. So the COM port should be open now. So I think we can say, let's pull it up just to make sure. We can say print number 1, and then I think probably a comma, and then we can put text. So alright, test. Looks like that didn't do anything. Alright. Well, y'all got to see the first shot at it, so I'm going to play around with it now and I'll come back. Well, I've played around with different settings for a while and I'm kind of getting the same results. I get a random character whenever I open the port and a random character when I close it, and I think the manual even mentioned that because it said something about I think the receive and transmit pins float whenever it's not actually connected, so that you'll get some trash at the beginning and the end. So that looks normal, but getting no data from here to here, and so I may have a wiring issue or something, but we may also have a solder joint or something this bad. So I think now we're going to have to go into troubleshooting, to the troubleshooting stage where we open the case up and hook the oscilloscope to it and look for signals. But it's getting late, so that'll be another day. Okay, I've played around with this for a couple days now. I can't get it to work at all. In fact, what was happening before, whenever I could open, but then when I try to print it wouldn't work. That I can't even open it anymore. So best I can figure. Let's see. Best I can figure is this DTR on signal. No, that's not right. DSR on signal is required for the open command to work. It doesn't completely make sense to me. I'm not sure if that's how BASIC used to work, but this is the area of the PC board where we had all the corrosion, and I also tried to touch up some of the solder joints. I think I made them worse. So I'm going to stop working on that now. Hate to keep switching around, but we got tapes in and we have a new belt. So let's try to see if we can get this tape player working. So I got it pulled apart. I don't know if you can see, the belt didn't break. It just slipped off this pulley right here. But it's because this belt's just not cut straight enough. It's hard to keep it. The width of it consistent with the razor blade since it's so small. But the new belt shouldn't have that issue, so I'll go ahead and get that installed. And that's the new belt installed. It's back together. So here's the old belt. You can see like right there. See, it's maybe just cut a little uneven. It's just plenty of little areas to catch on corners of pulleys and stuff, and it's kind of thin right there. So this new one should be good. Hopefully it doesn't rub anywhere. The website that I saw the size belt to get on it said 50 millimeter diameter and 0.8 to 1 millimeter belt thickness. So I got 1 millimeter, thinking it would you know, be stronger, last longer, but it's actually pretty close. Hopefully it doesn't rub on anything. Might be safer to go with the 0.8. Well, let's see if this is still cut on. I haven't charged this thing once. It's pretty impressive. I've used it a lot. So let's see. It's spinning. That's a good sign. Let's open one of these new cassettes up. Still isn't that easy to close. It doesn't line up the little sprockets very well with the tape. Not sure if that needs some lubrication or if that's just how it is. Maybe I just need to slam it harder. I was having trouble getting the tape deck off, and turns out you just have to pull it really hard. Okay, so let's see. Let's go into cassette. I think we're already rewound, but let's make sure. Yep, it is. Okay, so I think probably the easiest way to test it, instead of writing a basic program, is to try this ski writer, because I believe you can read and write 2 cassettes in it. So one is, well, it's got create document and use cassette. I'm not sure if we need to use the cassette to save it to the cassette. Let's just do create document. Alright. So I didn't know what to do. I hit break and it went to another menu. So let's say use cassette and save document. Document number, we'll say 1. Okay, so it tried to rewind, went forward a little bit. Should get a record light. There it goes. It says cassette error. That's not good. Let's try again. It doesn't seem like it plays while it tries to record. It's interesting. Yeah, I don't think it's gonna find it. Okay, well, I'm gonna try to see if there's somewhere I can lubricate something in there, because that seems like it's struggling to me. And then I'll try this a few more times. If I get it to work, I'll show you. If not, then I think we have to pull this apart and start troubleshooting traces again. So I put a little bit of lubricant on the gears there, and now the tape door opens and shuts easily, so that's good. But tried to save and record a few times, just kind of loosen it up. You know, let the lubrication get down into the bearings, and didn't start working. But so I decided I needed to open it up, and I didn't realize it, but the ribbon cable goes right next to where all the corrosion is. So I think all of our issues now are just kind of in this area where all the corrosion is. So I'm going to go ahead and pull the board back apart, take a look at it, and probably start desoldering and resoldering stuff. So I got the board back out, and this is kind of the area where everything that seems to not be working on this computer is at. So this is that connector CN8 right here that went to the tape recorder, and I don't know if you can tell in the video, the pins look pretty questionable. These are the two serial ports. This is the one we were plugging into, which is not the one that I was messing with. This is the one I was messing with. So that still has the solder joints in whatever condition they were. It's just hard to tell. They've got like a crust on them. It's hard to tell if anything's messed up or not. But and these chips right here look really bad around the base. These resistors have a lot of corrosion on them. So this whole area is kind of a mess. Everything else really looks good. So I'm just going to spend a lot of time and try to scrape this stuff off of here and probably take these components out and clean them and put them back in. So that's going to take some time. When I get somewhere with that, or if I find anything interesting, I'll be back. So I've already found something cool. So this is the soap water that I was using to clean the board a few days ago. And I guess maybe it has some battery acid and stuff in it. I'm not really sure. But look what it did to my aluminum brush. It's kind of neat. It's got some stuff growing on it. Anyways, thought that was cool. So I worked on this last night. Cleaned the board up a lot. I think it's looking a lot better. I redid all the solder joints. There's some really nasty stuff bubbled out of there when they heated up the old solder. But got all that cleaned out. I did remove some components and put them back in. The battery port right there, that actually, I don't even know if it was really making a good connection. I mean, obviously it was working, but I don't know if we were maybe running into some low voltage issues with the tape drive. But anyways, I'm gonna kind of put this thing together. We're gonna have to start troubleshooting the I/O lines to the tape drive and to the serial port, and I've kind of been putting it off, just hoping that playing around with it would get them working, just because this board's buried inside the machine because the keyboard sits on top of it. So I'm gonna have to hold the keyboard up and press stuff while I try to measure things. But I think we're to the point where we need to do that. I am gonna put it together enough to see if it works, since I did do the solder touch up. But I did continuity checks before, and everything was making a connection, it seems. So I don't necessarily think I fixed anything, but at least it's clean now. It's not going to get any worse, and we'll be able to probe the pins because they're cleaned off. So I'm going to start working on that. I'll come back if anything interesting comes up. I've pulled out the ribbon cable that plugs into the cassette drive, and it's just so I can kind of see this externally. I got a syringe and filled it up with a little bit of 3-in-1 oil, and kind of tried to get some into the ends of the motors where the shafts come out. And when I put it on the main motor here that drives the cassette, it made a sound difference. It sounded like it sped up. I wouldn't say it sped up because I think it's encoder speed controlled, but it definitely made a sound difference. And now the difference that I've noticed on the machine is if I rewind all the way and then do the slow forward, which I think is pretty much playback speed, it will start up. Whereas before I'd have to fast forward a little bit to get it to a point where it would go. So I'm thinking that that there was some resistance in there, and the backlash or whatever that's created when you rewind the tape all the way was too much for the motor to overcome. So it seems to be lubricated well now. I do not have a schematic for this board, and I wouldn't want to troubleshoot this board anyway. It's a two-sided surface mount board, I think it's two-sided, so that'd be pretty difficult. So hoping this board works. I also think that all the wires are working, because looking at the mainboard schematic, it looks like this is like a parallel or a serial interface. So I don't think anything would really be working. And the fact that we can play rewind and we have the position counter here, I think kind of suggests that the communication's working. So I'm going to go with that theory for now. So what can I do? So over here, there's 6 wires coming out the bottom of the PC board, and you can't really see where they go, but the 2 brown ones, let's see what's in here. The 2 brown ones come over here near the motor, and the motor has its own wires that come over here. So I'm thinking maybe that's just a sensor so that it knows that the playback head's extended, which leaves the orange and blue and the red and white wires. So 2 of those are probably for the playback head and 2 of them are for the recording head. I don't know what kind of voltage signals those get. I'm assuming it's something we could read with the oscilloscope, but I'm going to hook my scope to those and just kind of trial and error figure out what's what and see if I can see recording signals being sent to the record head, and if so, then see if we can see playback signals coming back from it. So if the recording signals aren't working, then there's nothing on this tape because it was a brand new tape, but maybe one of the other tapes will have something on it. Unfortunately, I don't have a mini tape player, so I can't, you know, play it and play audio off of it and see if it's making noises. So we'll have to kind of do it this way. But that's where I'm at now, and that's what I'm going to do. Well, I think I'm going to give up on the tape reader for now. There's definitely voltage going to the erase head, I guess. There's 2 heads in it. One's a little black one, and then there's the regular playback looking head. So I'm thinking the black one's an erase head. From what I read online, they're supposed to have a really low resistance, like 10 to 20 ohms. And this one, I mean, it's like 180 or something. So maybe it's bad. I'm not really sure. Out of the playback, I can't get anything on my oscilloscope. I don't know if there's nothing on there or if the signals are too low. But I think what I'm going to have to do is just get a micro cassette recorder. I don't own one. So if I get one of those, at least I can see if it's recording stuff on there, or maybe even record something on it and see if I can get some kind of response or signal so I can trace something. But I'm going to hook the serial port back up and see if we've improved that any. So at least we can get one more thing working. The serial port's really cool because you'll be able to download programs off the internet. So that's neat. And the tape recorder isn't 100% critical just to be able to write software and save it, because this machine actually saves its memory. It keeps its memory since it's battery operated. So as long as you don't let the battery completely drain, you'll retain your programs and stuff. So it's not the end of the world for now. So we'll be able to play with this thing without the tape recorder. But I would like to get that working. So like I said, I'm probably going to try to acquire a mini tape cassette recorder from somewhere and use that as a troubleshooting tool. So let me get the computer set up over here, and let's see if we can make any headway with the serial stuff. At least I can trace all that with the oscilloscope. Okay, finally making some progress. So messed around with BASIC. I was typing in the open statement wrong. So let's see. So it says open, and then you say whether it's input or output, and then the file number, and then the COM stuff. I was getting a BF error, which is bad file name or something like that, and I was focusing on this little area right here, but it was actually that. So I did try this a few times, and I was getting a syntax error, but I must have had a syntax error somewhere. But you see, there's an O, and there's a 0, and that looks like a 0. So I was putting a 0 there thinking it was 1 or 0 for input or output, but I guess it's actually I or O for input or output, which kind of makes sense. But like I said, I tried it and it didn't work. I must have done an O the first time when I was videotaping it, because it did work the first time. But we're past that. Even though I've done the soldering, I'm still getting trash over here on the screen, just like before. Basically, I think it does one character when it opens the port and one when it closes, which, like I said, the manual says it's going to do that. So let's see, let me get this set up. Okay, so the serial port's closed right now. So if we come over here, get the meter, pins, schematic. So pins 1 and 14 are connected to the positive negative 8 voltage supply for the RS-232 port, and I believe it's off whenever, I believe the supply is off whenever RS-232 port is not open. So I think pins 1 and 14 will read 0 right now. So let's check that. That is 6B. So that's pin 1, we got 0. Pin 14, we've got 0. Now let me open the COM port. Okay, so if we get around plus or minus 8, then that power supply is working, which is good. If not, then we probably got some bad capacitors. So alright, I got negative 7.94. And positive 8 exactly. So that's a good sign in a way, because it means our power supply is not a problem. But of course we're still getting trash on the computer. So either my computer program's not working, my cable's bad, or or the signals aren't being sent. So let me get the scope set up so we can see if we're getting signals out of the EPSON. I guess the baud rate could be wrong too, but let's see. Let me get that set up. I wrote a short little basic program, so I don't have to keep typing things in. So it should let's see, it'll alright, so I'm on the plus 8 volt rail. So if I hit run, we should see it come up to 8 volts and then go back down. 2, 4, yep, it does 2 volts per division. So now if I go to pin 6, we should see 8 volt data, or plus minus 6, or plus minus 8. 1, 2. Alright, so that's pin 6. And let's move this up so we can see it. And I'll go to let's go to 4 volts, 5 volts per division. Okay. Okay, that doesn't look like data to me. Let's try that again. Yeah, that just looks like it's kind of going low. Okay, so let's check the signal going into that buffer, which should be pin 10 of C7. Or 7C, which is right here. I think that's pin 10, and this will be a logic level. So let's make this there's data. Okay. So what was that? Pin 9. So pin 10 should be the output of that, which should be the same thing. Go to pin 10. I don't know if that's doing it or not. I need to figure out how to clear. There, okay. Alright, where are we at? 7C pin 10. So that's pin 9. That's pin 10 right there. And we do have data on the output of there. Okay. So pin 5 of 6B is where it goes next. 2, 3, 4. Pin 5. And we're not getting a signal there. So maybe there's a connection issue between that point, those 2 points. Alright, let me see if let me measure that and see if we're missing a connection there. If so, I guess I need to put another jumper in here. So here's the circuit I'm troubleshooting. This is the RS-232 connector. This is the transmit out. I'm getting a signal there. This is coming from the main micro processor. I'm getting a signal on pin 9, on pin 10, but not on 5 and 4. So let's do a quick ohm check. So that's 7C pin 10. So 8, 9, that's pin 10 right there. Meter where you can see it. Alright, and then 6B, I'm going to put the meter where I can't see. 6B pins 5 and 4. So this is 6B, 3, 4, 5. It's pin 4, pin 5. So we definitely don't have a connection between there. So I'm going to have to put another jumper wire on there. So I'll do that and I'll be back. I made the repair on the board. I couldn't see where the trace was before. It was under chips and stuff, so I don't know where the issue was, if it was in a via or if it was a bad trace. But it is right there where all the corrosion was. I did go through and test most of the other traces. I think everything else is good. So I put the program back in here because it cleared it when I unhooked the battery. And I haven't run it yet. See if I didn't mess the program up, but I'll put you over here on the screen. Alright, let me hit run. HX-20 serial port. Finally. Okay, so I need to figure out how to test the input. Okay, so I need to come up with a way to test the input. I think I'll probably just, I think I can maybe do a load command or something and try to send some text. But I'll work on that and see if it works, and I'll let you know. Okay, so the serial in is working. I'm not really sure how the load command works, but I'll show you what I did. So just to show you, I will list, and there's no basic programming here. So I said load COM0 like that, and it's loading. It's waiting for data. So then over here on the computer, I typed 10 print test, and then I sent that, and then I said 20 end, and I send that, and go back over here, and it's still trying to load. I don't know how to end it, so I'm going to hit break, and then we'll list, and there's the data. So it's definitely receiving. So now we have serial port working, we have printer working, we just don't have the tape deck working. So it's almost a fully functional computer, but I'm going to have to do some research on the tape deck. I don't know enough about tape heads to test them properly, and I need to come up with a mini disc or mini tape recorder so that I can see if anything's being recorded on there, or maybe I can record something on there manually. So that'll have to be in another video, but at least we've got most everything working. So because I got the serial port, I can transfer stuff to the computer, and I can get programs off the internet and put them on here. So that's awesome. So anyway, thanks for watching again, and I'll have another video out of at some point. I have a couple more projects I want to do before that, but anyway, thanks for watching.